So in this problem, we're having to take a look at the idea of coming up with possible values of the slope of a line of best fit. Well, as a reminder, the way that slope works, slope is the change in y for every change in x. Well, what we have to be careful of is that in statistics, we call x the explanatory variable. Explanatory. And we call y the response variable. So before I can even go further with this problem, I need to take a look and say, who is going to be my explanatory variable and who's going to be the response? So if I take a look here, I see that they're wanting to check the cost of an HD TV. So that's one of the variables, and screen size. Well, the question is, which one is the dependent and which one is the independent? So let's see. Does the screen size depend on the cost? If I think about this, I don't think that's a strong argument. I think the stronger argument is that the cost depends on how big the TV is. So I'm willing to say that screen size is the x variable and that cost is the y variable. And then putting that into statistics terms, screen size is the explanatory variable. And then the size of the TV is going, or the cost of the TV is going to be the response. So that means all of these numbers that I see up here for my options need to be converted into some kind of a fraction. So I'm going to put all of these over 1 because none of them are really in fraction form. So here's what they're saying, okay? The response variable y in this problem is measured in dollars. And the explanatory variable is measured in inches. So let's see if this makes sense. For every 1 inch, because remember all these bottom numbers are going to be inches, for every 1 inch, I'm going to get $70.70. Well, $0.70 is 70 cents. So we're basically saying that if you get a TV and you want an extra inch on the TV, you're only going to pay 70 cents extra. That seems a little low, so I'm going to go ahead and cross that out. Now let's take a look at E over here. If we increase the size by 1 inch, we're going to pay an extra $7,000. That seems a bit high. Well, for 1 inch, we're going to pay an extra $700. That also seems a bit high. So just intuitively, I've already knocked it down to 2 different possibilities, $7 or $70. Now, let's take a look at what this would look like with some actual numbers here. Based on the slope, if I start with a 33-inch TV, and I go to, let's say, a 36-inch TV, so start here and stop here, the change in size is equal to 3 inches. Well, if we use B as our possible slope, so if 7/1 is correct, well, then that would mean that the change in price would be equal to 7 times 3. Because for every 1 extra inch, we're paying $7 extra. So the change in price would be $21. Well, that, excuse me, that just doesn't seem right, because if you think about it, people would walk into the store and they would say, oh, I want to get the 33-inch, but most people want a larger TV, and they're going to be willing to spend the extra $21. So it's probably not the case that we're going to use B as the correct answer. In this case, if we increase the screen size by 3 inches and we use 70 as our answer, then that would mean that we would be able to say that it would be $210 instead of the $21. That seems to be a much more reasonable expectation. So I'm going to say that the best answer for problem 5 is answer C. Make that look more like a C.